right, number 12. When you divide like bases, you keep the base, you subtract the exponents, so you had to put a 1 on that y and say 10 minus 1, and you get y to the 9th. Number 16, when you have a negative exponent on a division problem, you can flip the division problem upside down. So I'm going to have y squared on the top and x cubed on the bottom, and that causes the exponent to be positive. When you have exponents on the inside and exponents on the outside, the rule is you multiply the exponents. So I'm going to have y to the 2 times 4 and x to the 3 times 4. So when I simplify that, I get y to the 8th and x to the 12th. Number 20, like bases, keep the base, subtract the exponent. So I'm going to have x to the 8 minus 9. Y is going to be 4 minus 1. And there is no z on the top, so I'm just going to leave the z on the bottom. You could have put a z to the 0 on the top and then did z to the 0 minus 1. So you'd add it all on the top. But this is going to give me x to the negative 1 y cubed over z. But you can't have negative exponents, so anything with a negative exponent flips. So the y cubed is going to stay where it's at because it had a positive 3. But the x to the negative first is going down to the bottom as an x to the positive first and z. And most of the time they don't put the 1s, so you can erase the 1. You could have left it, it wouldn't matter either way. Number 23, you have to simplify that quotient and write your answer in scientific notation. This is division, so I have to do 4.2 divided by 6, and then I have to do 10 to the negative 5th divided by 10 to the negative 3rd. So 4.2 divided by 6, 6 goes into 42 7 times, bring your decimal straight up. So that's 0.7. And then you keep the 10 and you do negative 5 minus a negative 3. So I actually have 0.7 times 10, and minus a negative is really plus a positive. So I actually have a negative 5 and a positive 3, which means I have to subtract. Keep the sign on the 5. The problem is 0.7 is not a number between 1 and 10. So to get it to be a number between 1 and 10, I'm going to multiply 0.7 by 10. But if I multiply 0.7 by 10, I have to divide 10 to the negative 2nd by 10. So 0.7 by 10 just moves the decimal over once. That gives me a number between 1 and 10, 7, times 10. And then I have to subtract the exponents. Keep the 10, subtract the exponent, so negative 2 minus 1. So I end up with 7 times 10 to the negative 3rd power. Okay, page 464, number 25. When you have an exponent on the inside of parentheses and an exponent on the outside of parentheses, they get multiplied. So 2 times negative 1 is negative 2, but you can't leave a negative exponent, so you flip upside down and you're going to have 1 over x to the positive 2nd. Number 30, that 5 actually has a 1 on it. So you're doing 5 to the 1 times 2 and w to the 8 times 2. So 5 to the 1 times 2 is 5 squared. 8 times 2 is 16, but 5 squared, 5 times 5 is 25. So I end up with 25w to the 16th. Okay, number 22. If I wanted to write 1.5 times 10 to the negative 7th, find the value of that, they're just asking you to multiply it out. So I'm going to have 1.25, and I have to move the decimal 7 places, and I have to go to the left because 7 is negative. So I can move it once, but then I'm going to need 6 zeros to make it a total of 7 places. So this is going to equal a decimal point, 6 zeros, 125. 36. State whether that number is in scientific notation. If not, write it in scientific notation. It's not in scientific notation because 50 is not a number between 1 and 10. So if I want to take 50 times 10 to the negative fifth, 50 is not between 1 and 10, but if I divided it by 10, that would give me a 5. But if I divide the 50 by 10, I have to multiply the 10 by 10. So when you multiply, you keep the base and you add the exponents. So I would end up with 5 times 10 to the negative fourth for that to be considered in scientific notation. Number 60, you have to solve that by elimination. The problem is I don't have any variables that have odd opposite numbers in front of them. But the 3 and the 1 could become opposites if I multiplied the top row by negative 3. So I'd have a negative 3 times 1x is negative 3x. Negative 3 times negative 6y is positive 18y. Negative 3 times negative 3 is positive 9. Then I can add it to my second equation, and the x's are going to get eliminated. So when I add these together, x's go away. 18y plus 4y is 22y. 9 plus 3 is 22. Divide each side by 22, and y is 1. Then go back into either equation. I'm going to go into the first one. X minus 6 times 1 will equal negative 3. Well, negative 6 times 1 is a negative 6, so I can add 6 on each side. So if I do a negative 3 plus 6, I get a positive 3. So my answer is positive 3, positive 1. So if I checked it in the second one, 3 times 3 is 9, 4 times 1 is 4, 9 plus 4 is 13. On 29, since negative 6 is not in parentheses, I prefer to think of this as negative 1 times 6 to the negative second. So this becomes negative 1 times, you can't leave that negative, so you flip it upside down, make it a positive. So then you have negative 1 times negative 1, and 6 times 6 is 36. So you end up with negative 1 over 36. For 48, that 4 has a 1 on it, so it stays in the top because it had a positive exponent. But the x of the negative 6 has to flip down to the bottom, and the y of the negative second has to flip down to the bottom.